Hello, and welcome to the Unit 8 review, our last unit test of the school year. That is crazy. We finally got here. I am going to miss all of you. I'm talking directly to my students and also to those of you utilizing my videos. Anyways, let's get started. Number 1. If the overall truth value of the conditional statement is as follows, what are the truth values of P and Q? Okay, so the first thing that I'm going to do is fill out the false one, because that's how I did it. I memorized the one false one, and then it's a little easier to fill out the truths. So the only time a false value can happen is if we start off with our hypothesis P, true, and end with our conclusion as false. So that's the only false one. Okay, let's do the truths. I think the most obvious truth one is true, true. Two truths make a true. A false hypothesis and a true conclusion leads us to an overall truth value. And lastly, if both the hypothesis and conclusion are false, then it's true. The way I like to memorize that part, because it's kind of weird having two falses equaling a true. Remember that saying, two wrongs? Nope, never mind. Two wrongs can't make a right. Or is it can make a right? I think it's can't. Anyways. Back to math. All right, there's only one false one, okay? Let's just stick to that because the phrase is eluding me. For number 2 and 3, consider the conditional statement. If AB is the perpendicular bisector of CD, then CD equals to CB. What is the hypothesis? Well, the hypothesis is always the first part of our statement, which would be AB is the perp of CD. Just saving myself some writing right there. I'm okay if you do that too. The conclusion will always be the second part of our statement. So in this case, the conclusion is CD equals to CB. Number 4. Complete the truth table for the conditional statement. Now, I believe in the version that I printed out for you, I have a place there for you that you can write out the actual sentence. I'm going to speak it out loud. Okay, the conditional statement that we have is if you live in Chicago, then you live in Illinois. So that's two truths, and that gives us a true. All right, now let's say we started off with a truth and ended with a false. It would sound like this. If you live in Chicago, then you don't live in Illinois. That doesn't make sense. There's only one Chicago, and it is in Illinois, so our conclusion is false. The next one, what if the hypothesis was false, but the conclusion was true? If you don't live in Chicago, then you live in Illinois. And you know what? That is true, because there are lots of other cities in Illinois that aren't Chicago. We live in one of them. All right, and how about the two falses? It would sound like this. If you don't live in Chicago, then you don't live in Illinois. I mean, yeah, sure. You could live in New York, and New York City, New York. So, true, true. All right, number 5. If angle ABC forms a linear pair with angle CBD, use the linear pair postulate to determine the value of x. The linear pair postulate tells us that if we add two angles that form a line, a linear pair, they equal 180. So, I'm going to do 5x, that's the angle ABC, plus 13x plus 36, that's angle CBD. Together, they equal 180, and I'm going to go ahead and zoom in on that. All right, I'm going to begin solving this by, I forgot an x right here, by adding these like terms, the x's. 15x's plus 13x's give us 18x's. And then we still have plus 36, that just continues. We just bring that down, equals 180. Next, I'm going to undo the plus 36 by subtracting 36 from both sides of the equal sign. On the left side, I'm left with 18x. On the right side, 180 minus 36 give us 144. And I'm going to conclude this problem by dividing both sides by 18. And I'm dividing because 18x is actually 18 times x. So I'm undoing the multiplication with division. And we are left with x equals 8. Voila. And we have finished. Onwards we go. For number 6 and 7, I would like us to write the congruent statements represented by the markers of each diagram. So we're going to look at the tick marks and the arcs of the angle and write down what they represent. Okay, let's start with number 6. The first thing that I'm going to do are the lines. So I see, or the line segments. I see this line segment marked and this line segment marked. Okay, the one on the, I guess, upper part, I'm going to call it AR, and I'm going to put a little hat on it to represent that it's a line. And the one on the bottom is YR. I do not know why I just wrote an X. What was that? I think my brain malfunctioned. YR. Okay, next, oh, don't forget the little hat on YR. Next, we're going to do the two angles. I'm going to begin with this kind of upper one. I am going to name this angle AMR. Notice how I picked it. I made sure that first I wrote down the angle, and the angle that I'm referencing, the letter that holds the angle, is right in the middle. And that's going to be the same for the one on the, I guess, more bottom area. I'm going to name this angle YMR. Angle YMR. Notice again, I'm referencing angle M, and that's the letter in the middle. Let's do the same thing for number 7. I'm going to start off with the lines that are marked. I have a line marked right here. I'm going to call that ZY. And then I have a line marked right here. I'm going to call it MY. And don't forget to put little hats on top of them to represent that they're lines. Next, let's label our angles. I have this angle right here, which I'm going to call SYZ. I want to make sure the letter Y is in the middle because it holds my angle. Angle SYZ. Let's do the one on the other side. I'm going to go AYM. Angle AYM. Once again, Y is in the middle because that is what holds our angle. Okay. For questions 8 through 12, determine if there is enough information to prove that each pair of triangles is congruent by side, 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 or angle, side, angle. Write the congruent statements to justify your reasoning. Okay. In the figure shown, ABC and ADC are isosceles triangles with the base AC and DC. And angle BAC and CAD are congruent. Let's first do that part, the two angles that are congruent. BAC is this angle, and CAD is this angle. Okay. Now, these isosceles triangles have two bases. Oh, each of them has a base. One of the bases is AC, which means this line will have two congruent angles on the bottom. So if this BAC is congruent, then we have BCA. They should be congruent to each other. Next, I have the bottom of DC. That's right here. Those are going to have their own angles that are congruent. Now, I already see here that this is not really going to work out because the triangle ABC doesn't even have the double angles. But let's write down one other thing that they have in common. And we can say that they have AC in common. If we really wanted to go further, you can comment on the fact that isosceles triangles have two sides that are congruent right here. And same with this one. Now, unfortunately, we do not have a situation where we can have a congruency here because these lines and angles are all kind of different. So I would say no. Congruent statements, I guess we'll go a little cuckoo for Cocoa Puffs and write down everything that I marked. Because why not? Why not? All right, first we have those purple angles with one arc, in case you can't see that color. We have BAC, CAD, and BCA. Then I'm going to write down the two blue angles, ACD, so that's the double arcs, in case you can't see the difference of that color, and ADC. I'm also going to write down the two congruent sides with one marking. That would be the green one. That would be side AC and AD. And I'm also going to give us that pink one, AB. So that's the one with the two markings, and BC. If you didn't give me all of that, that's fine, but they are not congruent. They just, I'm sure you can see by the pictures, their sides are all different, their angles are all different. Okay, number 9. Let's check out this triangle. So what I'm noticing here, first and foremost, is I have this side marked as congruent. I also notice both triangles have a 3 millimeter side and a 4 millimeter side. Success! This is congruent by side, side, side. Wonderful. Let's write them down. Let's get started with the 3 millimeter side. So that would be AN is congruent to GE. Next, the 4 millimeter side, AR is congruent to EO. Last, let's do the side that's marked with a single tick mark. Now, I personally know that this is 5 millimeters. It's a 3, 4, 5 triangle. That's a Pythagorean triple. MR is congruent to GO. Wonderful. Now, it doesn't matter if you wrote any of these statements out of order. As long as you have all 3 statements, we're good to go. Number 10. Okay, so I see 2 angles marked. So that's 2 A's. So can I make this ASA? Let's mark that down, by the way. Angle, 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 angle. Can I make it have a side in the middle, in between the 2 angles? Indeed I can, by the reflexive property. Finally, a congruent triangle by ASA. Let's write it down. I'm going to begin with a single arc because that's what I feel like doing. The one on top, I'm going to call it angle AMR. Remember, very carefully, make sure the angle you're referencing has a letter in the middle. Next, I'm going to name the one on the bottom angle YMR. Next, I'm going to write down the side that's in the middle of them. MR is congruent to MR because of the reflexive property. And lastly, let's do the double arcs. Angle ARM, remember, the letter of the angle is in the middle, is congruent to angle YRM. Did I write an X again? What is with my brain? YRM. I just want to write X's. I don't know. Oh, excuse me. All right, number 11. Okay, so I see a side and an angle. Do they have anything else in common that I can mark? They actually do. I can mark this middle line. Okay, now let's see if they're congruent. An A, an S, an S, an A, and oh. No, our triangles do not have a congruency of ASS, and the way I remember it is 2-dimensional figures do not have an ASS. All right, let's write down the congruent statements. These triangles may not be congruent, but they have congruent sections. First, I'm going to write down the congruent angles. I have angle E, congruent to angle A. I can use one letter because it's using the whole angle. Next, CA is congruent to SE. Don't forget the little hats on top. And the middle one, CS, is congruent to CS. All right, onwards to number 12. Okay, so I see 2 angles marked. I see 2 sides. Can I mark anything else? Yeah, I can mark the middle one. Are they congruent? Indeed they are, by SAS. SAS. Let's write it down. I'm going to write down the ones with 1 tick mark. EF is congruent to GF. Then I'm going to write down my angles. Angle EF, what's on top? D, is congruent to angle GFD. Notice that F is in the middle because that's the angle I'm using. And lastly, let's write that middle line. DF is congruent to DF. Beautiful. All right, let's take a look at number 13, 14, and 15. In these, we're going to practice using a process of elimination to see what we need to make these triangles congruent. Okay, so number 13 asks us to make these 2 triangles congruent by angle, side, angle. And it seems like we already have our side. What are we missing? 2 angles. So I'm going to cross off option A and option B because I don't need them. They're sides. Now C and D both start off with angle K is congruent to angle R, so I'm going to go ahead and mark that right away. Because regardless of which one we pick, they both have them. Now before I pick my option, I want to mark the next angle that should exist in order to make it ASA. So AS, the angle should be here. AS, the angle should be there. So I should have angle M and angle T that lives in option letter C. Let's do the same thing with number 14. In this problem, we want to make these two triangles congruent by side, angle, side. And we are already given the angle. Therefore, let's cross off the angle options. We do not need them. Goodbye, letter C and D. A and B both start with KM is congruent to RT. So let's mark that. KM is congruent to RT. Now I want to make sure this is side, angle, side. So let's see. Side, angle, this side should be marked. Side, angle, this side should be marked. So side, side. So that's KL and RS. Oh, that looks like it lives in option A. Next we have number 15. We want to make these triangles congruent now by the side, side, side. We have one of the sides marked. Since it has 2 tick marks, I'm just going to assume it's the second side. We don't need any angles at all in number 15, so I'm going to cross off C and D once more. Here we have KM that's congruent to RT in both of them, so let us mark it, KM, RT, which leaves us with these lines, ML and ST. Let's see which option that lives in. Option B, wondrous. Onwards we go. Number 16. Suppose angle M is congruent to angle Y. What information would we need to conclude that these true triangles are congruent using side, angle, side? Okay, well, they gave us the angle. Let's mark it. Angle M and angle Y. All right, so that's the angle. I want 2 sides surrounding it, which means I need this side and then this diagonal side. So I'm going to write down MA. Oh, I already used purple. Let's use a different color. Blue. MA is congruent to YR. And then also, I'm looking at this long diagonal line. MR to be congruent to YA. That would make it side, angle, side. So MR congruent to YA. All right, onwards we go. Number 17, suppose line MA is congruent to line YR. What information would we need to conclude that these two triangles are congruent using angle, side, angle this time? Okie dokie. We are given one of the sides. Let's mark it MA, YR. So that's our S. We need 2 angles surrounding it. So I want all of M, all of Y, all of A, all of R. So let's name them. We need angle M and angle Y. Angle M, angle Y. And you could also write angle A, because I need the whole angle. Angle R, I need the whole angle. Not just pieces of it, the whole angle. Okie dokie. Now, if you gave me 3 letters for A and 3 letters for R, you're still right. And let me write that down, because I think some of you might do that. MAR is congruent to YRA. If you wanted to do it that way, that is also correct. It's just way more specific than I got. All right, number 18. Suppose line MR is congruent to line YA. What information would we need to conclude that these two triangles are congruent using side, side, side? Oh, I love side, side, side. That's usually the easier one to do. Okay, so MR and YA, those are diagonals. So MR and YA. So what sides does that leave us with? Because we need all 3 sides. Side, side, side. That leaves us with this side right here, MA. It is congruent to this side right here, YR. And we can use the reflexive property on the bottom to say that AR is congruent to AR. Number 19. Suppose segment AB is a perpendicular bisector of CD. All right, let's draw that. I need to draw it first. Perpendicular means it creates right angles, so we make little boxes. Bisector means it splits the line in half, so two perfect sides. Okie dokie. All right. So our two line segments are CB and DB, and our two angles end up being angle ABC. Remember, B is in the middle, and angle ABD. All right. Number 20. Suppose ER is a perpendicular bisector of GO. Are there congruent triangles in this diagram? Explain your reasoning. Well, let's check it out. I'm going to draw the perpendicular bisector. I need to see it. It forms two right angles and two perfect halves. What else can I mark? I can mark this middle. So are they congruent? Indeed they are. By side angle side. And let's write them down. It gives us side GE and OE. It gives us angles GER and angles OER. Remember, E's in the middle. And then, of course, reflexive property. ER is congruent to ER. Wonderful. Okay, 21. Oh, we're almost done. Wow, this has been a long video. Let me take a sip of water. Excuse me for a moment. Okay, for the following figure, Miranda determines that sides DF and AC are congruent. I'm going to mark it right away. DF and AC. They also measure angle C and angle F, and notice that they're congruent. Angle C, angle F. Then they conclude that they're congruent by SAS. Is that enough information? Is Miranda correct? So the thing is, not enough info, but she's right. Or, I don't know, they are right? Miranda, let's write Miranda is correct. Why is Miranda correct? Well, we have CB and FE horizontal, they're perfectly straight, right? They're not diagonal, and I can count that they each have 3 blocks, so I can actually mark them as congruent. All right, so not an information, but she is correct. All right, for the following figure, Steve determines that sides DK and BC are congruent. DK, BC. He also measures angle K and angle C and determines that they're congruent. Angle K, angle C. Finally, he measures EK and AC and determines that those are congruent. Good thing he's measuring those because we don't know how to do that yet. You will learn next year. He concludes that the triangles are congruent by SAS. Is that enough information? Is he correct? Yes. Steve is correct. You're explaining your reasoning can be through the diagram. So you're showing me that DK and BC are congruent. That's the side, the angles, and the side. If you want to go even further, you could label it SAS to show me that they are in fact congruent. All right. Wow. Thank you for sitting with me through this long video. Good luck on your final test, and I'll see you in one last video for the final review. Have a wonderful, whatever time of day it is for you. Bye!